For writing chemical formula, we need to know about the oxidation state of different atoms. For example, if there's a group 1, so they have outermost one extra electron in their shell. So they have to lose their one electron, while in group 7, they have the 7 electron in their outermost shell, and they need 1 electron to complete 8 electron in their outermost shell. For example, if you take the sodium, that is 11 electron, and these electrons are arranged. First shell contain 2, while the second shell contain 8, and the third one is contain 1. While the chlorine, this contain in first shell, there is a 2, the second contain 8, and the third one contain 7. To complete 8 electron in their outermost shell, the sodium has to lose 1 electron, while the chlorine has to gain 1 electron. So in this way, if the sodium is losing 1 electron, and this will go into outermost shell of the chlorine, and this will produce the octet rule. And this octet rule, so sodium will gain its octet rule, outermost electron will become 8, but the number of proton become greater as compared to the electron, and this will get a 1 positive charge. While the chlorine, when it will get the outermost electron 8, but the number of electron will increase, and this will produce 1 negative charge, and its shell will increase the overall diameter. Now, in this way, the sodium, all metals of a group 1, they're getting +1 oxidation state. Why? Because they are losing 1 electron. While in a group 7 of periodic table, so all atoms are getting -1 oxidation state because they are gaining 1 electron to complete their octet rule. How we can write their formula? For writing their formula, we need to write their symbol of atom with the correct charges from the periodic table, and then balance their charge to make a neutral formula. For example, if the sodium is losing 1 electron and the chlorine is gaining 1 electron, and in this way, the sodium will get +1 oxidation state, while the chlorine is getting -1 oxidation state. We can write, so +1 and -1, these are the same charges, will cancel each other and produce sodium chloride. And this sodium chloride is a delectable table salt, which is making salty our cuisines. We're going to take another example from the group 2. In periodic table group 2, the all atom, they contain outermost 2 extra electron in their shell, and they will lose their 2 extra electron, while the group 7, they have the 7 electron, they gain 1 electron. For example, if you take magnesium, this magnesium is losing 2 electron, while the chlorine is gaining 1 electron, and in this way, the magnesium with a +2 oxidation state, and the chlorine is -1 oxidation state. So the +2 oxidation state, we can write below the chlorine, while the -1 oxidation state is going for the magnesium. No need to write 1. So in this way, we can make our formula magnesium chloride. In the same way, we can select another, for example, beryllium is losing 2 electron, while the chlorine is gaining 1 electron, and this will make by +2 will go below the chlorine, and this will produce barium chloride. So this is one that's going to produce beryllium chloride. For the barium chloride, for example, if you're going to take this one, so this barium chloride, so barium with a +2 oxidation state as like other family members of the group, and this will behave similar way, and they produce barium chloride. We're going to take another example for the calcium. This calcium is losing 2 electrons, while the chlorine is getting 1 electron, and the calcium contains +2 oxidation state as like other all members of the group 2, and this will make calcium dichloride or calcium chloride. We're going to take another example from the group 6 and the group 2. Now in this group 6, they contain outermost 6 electrons. So in this way, they will gain 2 electrons to complete their octet rule. While the magnesium, this belongs to the group 2, this will lose 2 electrons to complete their octet rule. And in this way, the magnesium is getting +2 oxidation state and oxygen with a -2 oxidation state. They will cross, the +2 and -2 will cancel each other, and this will produce magnesium oxide. So if there are the same charges, they will cancel each other, and we can write that with the same ratio, 1:1. We're going to take another example, the one member from the periodic table group 3 and getting the oxidation state +3 oxidation state, while the chlorine from the group 7 -1 oxidation state. By the cross, the +3 is going below the chlorine and -1 with the aluminum. No need to write 1. And in this way, this will produce aluminum trichloride with the ratio 1:3. We're going to take another example. Now, in this example, there is something unusual. You can see the sodium with a +1 oxidation state. What? The carbonate with the -2 oxidation state. Now, this carbonate is molecular ion. This molecular ion is behaving like, for example, the carbon with the valency 4, it is making the 4 bond with oxygen. So 2 bond with 1 oxygen, this will satisfy it. While the 1 bond with another and second and third oxygen, so they will get 1 negative charge. So overall, carbonate will contain 2 negative charge. So oxidation state of the carbonate will be -2. So in this way, the -2 is going below the sodium, while the +1 is for the carbonate. No need to write 1. And in this way, that will produce our formula. So disodium carbonate, or generally we can say a sodium carbonate, will complete its formula, and that will be a final neutral state. We're going to see another example. So if there are the 2 molecular ion, one is ammonium ion and second is sulfate ion, and that is producing ammonium sulfate. Now, how they are getting charges? For example, if you take the sulfate with a minus charge, so sulfur belongs to the periodic table 6, and in this 6 group, it is making maximum bond 6. While the 2 oxygen, they contain 1 bond. So in this way, 1 electron is extra, and they're getting 1 negative charge. So overall charge will come 2. So that is -2. While the ammonia that contain this nitrogen will share 1 extra electron from outermost shell, and the nitrogen is getting 1 positive charge. And due to this 1 positive charge, overall ammonia will get +1 oxidation state. Now, these are the +1 and the +1 oxidation state and -2 oxidation state. They are different. So we're going to write so that there are the 2 ammonia are going with the 1 sulfate molecule with a ratio 2:1. And that is producing ammonium sulfate, so or NH4 tri-SO4. We're going to take another example. If there is ammonium react with the nitrate, and this is producing ammonium nitrate. In this way, ammonium nitrate, so the nitrogen is making 4 covalent bond with the hydrogen, in which 1 is the dated covalent bond. So in this way, due to the extra electron share by nitrogen, this is getting +1 oxidation state. So overall charge will come on ammonia, that will +1, and that produce ammonium molecular ion. While the nitrate, so nitrogen is making 4 bond with oxygen. Now 2 oxygen are with a single bond contain -1 oxidation state. So -1 will cancel with the +1 of the nitrogen. Overall charge will come -1 on the nitrate, and this will produce -1 and +1 will cancel each other because these are the same charges, and we can write ammonium nitrate with a ratio 1:1. We're going to take another example. If there is a group 1 potassium, so this group 1 potassium is reacting with the sulfate with a -2 oxidation state, while the potassium with a +1 oxidation state. So these charges are different, and in this way, 2 potassium can satisfy the 1 sulfate molecule and to produce the neutralized state. And in this way, that is producing K2SO4. So 1 with a ratio is going to produce 2:1. For example, the 2 potassium and 1 sulfate. So overall ratio will be 1:2, or you can say 2:1. We are heading to another example. In this example, if you have a calcium with a +2 oxidation state and a hydrogen carbonate, this is -1 oxidation state. Now, carbon valency 4, it is making overall the 4 bond. One oxygen is satisfied by the double bond, while another oxygen is satisfied with a 1 bond with a carbon, other from hydrogen. So one oxygen is unsatisfied because there's 1 electron is extra. And in this way, this will get -1 oxidation state. And this -1 oxidation state will come overall in hydrogen carbonate. So these are different charges, the calcium with a +2 oxidation state and hydrogen carbonate with a -1 oxidation state. It will be written below, and that's going to produce the calcium hydrogen carbonate. So CaHCO3 tri. And the ratio is becoming 1:2. We're going to take another example. If the calcium with a +2 oxidation state, while the hydrogen overall is producing -1 oxidation state. And this will produce the calcium dihydroxide, so CaOH tri, and that is producing 1:2. There is another example, the group 2, the copper with a +2 oxidation state, while the sulfate with a -2 oxidation state. Now, these are the same charges, so sulfur is making the double bond with the 2 oxygen, and they're satisfied. While the 1 oxygen with a 1 negative charge because they're having the 1 bond with the sulfur. And in this way, overall, 2 negative charge will come on the sulfate, and this will react, and the +2 will cancel the -2 because these are the same charges. And in this way, that is producing copper sulfate with a ratio 1:1. We're going to move to another. The magnesium is reacting with the nitrogen oxide or nitrate. So if there's a react with a nitrogen trioxide, so that's overall charge is coming -1. And in this way, that is producing magnesium nitrate. And this magnesium nitrate, MgNO3 tri, so it's coming with a ratio 1:2. We have done the overall, the concept. We're going to see some related question. The electronic structure of atom P and Q are shown there. Now, P and Q form an ionic compound. What is the formula of the compound? So we need to know the formula of the compound. Now, the P outermost electron in P are how many? They are 1, 2, 3, 4, 5, 6. So mean the P need 2 electron in outermost shell, while the outermost electron in Q is 1, and it has to lose 1 electron to get octet rule. So the P is gaining 2 electron and getting -2 oxidation state, while the Q is losing 1 electron and getting +1 oxidation state. And in this way, this is producing overall the formula PQ2. So our D is our correct answer here. We're going to move to another question. The electronic structure of the 2 atoms P and Q are shown. So P and Q combine together to form a compound. What is the type of a bond in this compound, and what is the formula of the compound? For example, the P contain outermost 7 electron, while the Q contain 1 electron. So to attain outermost 8 electron, P has to gain 1 electron and get -1 oxidation state, while the Q will lose 1 electron to get +1 oxidation state, because the Q is getting duplet rule, while the P is getting octet rule. And in this way, they have to gain or lose the electron. So if there is a gaining electron and the losing electron is involved, so that will form ionic bond. And in this ionic bond, +1 will cancel the negative one. And in this way, overall charge will be, that's a 0. That will produce a neutral state. And this will produce our P and Q. And A is our correct answer. We're going to see another question. The formula of the some ions are shown there. So these different ions with our different ionic states is visible in the table 1. So in which row is the formula not correct? So we need to find the formula which is not correct. For example, we're going to start checking from A. With the help of this rule, for example, A, aluminium with the oxidation state +3, while the oxygen with a -2. Because aluminium belongs to the group 3 and the oxygen belongs to the group 6. Now, in this way, by the cross, and we are getting Al2O3. So while it is correct formula, and we look for another option B. Let's check in the option B. So this is the iron with a +2 oxidation state, while the nitrogen with the -3 oxidation state. And that can cross and this is going to produce Fe3N2. But if you see in the option, it is written opposite. Fe2 and 3 is a wrong formula. So our wrong formula is B in this option. So in this way, we shall move from A, B, C, and D and identify the wrong formula. We're going to move to another question. The formula of the some ions are shown. Which formula is not correct? For example, if you're going to see the first one, so the aluminium is reacting with a sulfate. So this aluminium with a +3 oxidation state, while the sulfate with a -2 oxidation state. Now, in this way, by the crossing their charges for their oxidation state, and it's becoming Al2SO4 3. Now, this Al2, so SO4 3, so this is producing opposite in option A. While in option A, it's giving Al3, so that is wrong. We're going to see another question. The 2 atoms of magnesium react with the 1 molecule of oxygen. So what is the formula of the product? Now, how many atoms of magnesium or oxygens are there? They always follow the same rule in combinations. For example, the magnesium with a +2 oxidation state, while oxygen with a -2 oxidation state. Now here, the both are having the same charges, so they're going to produce magnesium oxide with a 1:1, and that A will be the correct answer. We're going to move to the next question. The compound contains 1 atom of calcium and 2 atoms of hydrogen and the 2 atoms of oxygen. So what is exact chemical formula of these compound? So we're going to see that the exact chemical formula to get that. So in this way, for example, the calcium with the oxidation state +2, while the hydroxyl, the oxidation state -1. And in this way, due to the different charges, we can write the +2 is going below the hydroxyl, while the -1 with the calcium. And we can write this formula, calcium dihydroxide, and in this response, our correct option is D. Here, there's a kind of the unique question in which we need to know about the number of different atoms. For example, the formula of the compound W, X, and Y are shown. Now, which statement is correct? If you're going to see that the statement number D is saying, so Y contain the same number of hydrogen and the oxygen atom. So if we see that the Y, so the number of hydrogen atom are 6 multiplied 2, these are 12. While number of oxygen, so these are 6 in water, while the 6 are in nitrate. So 2 multiplied 3, that will become 6, and 6 plus 6 are 12. So it means 12 number of hydrogen and 12 number of oxygens, they are same in Y. So in this way, the Y will be the correct option. So structure questions might possible relevant to the formation of ionic compound. For example, aluminium chloride. So we can write this formula in this way by following that rules. And arsenic oxide and silicon bromide. And in this way, the phosphide or barium or francium. So this type of questions might possible. Here we got idea how to write the chemical formula of ionic compound. So while the formula writing strategy for the molecular compound or the molecules which contain covalent bond is a bit different. For that, you can follow the other video. Thank you. Thank you very much for watching.